So today we will talk about the composition of functions, and until now we have added functions, we've subtracted functions, we've multiplied them and we divided them, but this is a new thing we do with our functions, and in this case we are composing them together. Now what does that mean? So let's take a look at the picture on the right here. So in this picture we have two functions. We have the function g and the function f. And we also have an input, that is our x here. Now that x gets inputted into the first function g, and that g, so our function g, spits out an output which is g of x. That's our corresponding y that we get over here. Now that output, that g of x, gets now inputted into the next function f, and that function again takes the input and spits out an output. Now that output is f of g of x. So that is our final output. So g of x was the intermediate output, which then becomes the new input, but then our final output is our function f applied onto the output of our function g, which was applied on our input x. So all in all, we can think of it as if a third function is acting on the input x, our original input, and then spits out our output f of g of x. And that third function we call our composed function, composed of f and g, and it is defined here on the left as f composed with g acting on x is defined as f of g of x. And we can read that f little circle g as saying f composed with g or f of g, depending on what we prefer or what we are doing in that moment. Now usually we call g of x, which gets inputted as an input, the inside function, and then our f, which is applied second after g, as the outside function. Now when we want to know what x's are we allowed to put in to our composite function, then so that means we want to know what is our domain of our composed function, then we need to first think about what x's are we allowed to put into g, so our inside function, but we also then need to take a look at what are we allowed to overall put into our composed function, because even though we might be able to put some x's into g, maybe it spits out some outputs that then do not work for f. So we have to look both at the g of x but also at the overall function. So we have to look at the domain of both, and we will do that later on. For this video we are not looking at the domains, we're just looking at how that works with composing two functions. So let's take an example. So we're looking at the example here where f of x equals 4x squared minus 1 and k of x equals 3x. And the first example we will be looking at is A, where we're composing f with g and applying it to our input of -1. So let's go back and think about for a moment what our definition was up there. That means f composed with g of -1. So we can rewrite our composed function of f composed with g of -1. Now I'm noticing that it says g here, and here our second function is k. So I'm just going to rename k as g to make it a little bit easier. G of x equals 3x. And so then I'm going to rewrite our composed function as f of, and I'm going to take two different colors to rewrite our functions. I'm using a third color in the beginning to name our original input. So now what we do is we're basically working our way from the inside out, right? Because when we say f composed with g, that means we're applying g first and f second. So I'm going to apply g, and the input for g is -1. So I'm using my function g of x, which is 3 times x, and so we have 3 times, and our input is -1, like that. So now we can do 3 times -1, that is -3. So we get f of, and so our output of g is -3. And now that -3, which a second ago was the output of g, becomes now the input for f. And so we are rewriting this with our formula for f, which is 4 times x squared. Now our x here is -3, so 4 times -3, and that gets squared, -1. Now that becomes 4 times 9, and that is 36, -1 is 35. So when we go back to the picture, that x there that we originally inputted was -1, then our g of x, the output of our g, became -3, and then that gets inputted into f, and that becomes then the final output of 35. Now, as we said already multiple times, g came before f. Now what if we want g to be the second function and f the first one? Well, then we turn everything around. We say we are composing g with f. So that is our example b here, and so that now goes exactly the other way around. So I take my outside function will be g of x, and then my inside function is f, and my input again is -1. And again we'll be applying our input to our inside function first. So we get for f, we get 4 times, and that will be now our input, -1. We square that and -1. And now we do the math on the inside, which is -1 squared is 1, 4 times 1 is 4, -1 is 3. And now we apply that 3 to our second function g. So we get 3 times, that's the 3 from our function g, and we multiply that with the 3 of our, that's our output from our function f, and that will end up 9. Now as the last step, we're going to think about, okay, so we did that for each function for -1. Now what if I want to also find -2, or +1, or +15, or -21? Any number. I want to run several numbers, and I don't want to redo this whole process every single time. Then what we're going to investigate now is, well, what if I just keep my x? So instead of using a specific number to input, what if I just input my general x? So if we go back to having our f composed with g, then I'm going to again take my inside function, then again I'm going to take my outside function f of, and then my inside function g, and then my general input x. Well, let's plug in our general formulas. So our general formula for g of x is 3 times x, our input, and then we plug that into our formula for f, which was 4x squared minus 1. So I get 4. Now this is my x. My x is 3x in this case. Squared minus 1. So clearly I will not get a number as an output, but I will get a recipe that's a little easier than to use at the end. So if I simplify using exponent rules, I get 4 times 9 times x squared minus 1, which ends up 36 x squared minus 1. So if I think back to my input of -1, and I would plug that in here, well, -1 squared is 1, 36 times 1 is 36, minus 1 is again 35. So that still works. I still get the same output, but I get it a lot faster than with all the work we did up in A. So let's do the same thing one more time the other way around for our function g composed with f, which we can rewrite as g of f of x. And now we are first plugging in f of x, which is 4x squared minus 1. And then we plug that whole expression on the inside of the parentheses into our g of x. Our g of x was 3 times x, but in this case our x is 4x squared minus 1. And so all that's left to do in this case is distribute our 3, which gets us 12x squared minus 3. And so if you check our work with our input of -1 again, -1 squared is 1, times 12 is 12, 12 minus 3 is 9, like the answer we just had in B. So that is the general way we work with composite functions, and in the subsequent videos you will then get exposed to some other ways of looking at it, as well as some other algebraic examples.